the first way that we can evaluate a limit without looking at a graph or creating a table of values, and sometimes we will need to use those properties to break down the limit or things like that, is we can actually use direct substitution. A lot of times direct substitution does work. These aren't necessarily the type of problems that are going to be really common on like an AP test or something like that. But direct substitution can be a very, very helpful way, because when we think about when we've talked about continuity, we said that if the limit as x approaches some value is the same thing as the output, and remember we said the limit as x approaches c for some value equals whatever that limit is. If this is the same thing as f of c, if these are both the same, that was our definition of continuous. We said, yes, it has continuity at this value if the limit is the same thing as our output. So it would make sense that if it's continuous at this value, then that's simply going to be what the limit is. We can just kind of work backwards, and that's by using direct substitution. The limits of polynomial and rational functions can be found by direct substitution so long as the denominator of the rational function evaluated at c is not 0. So direct substitution always works for polynomials because polynomials are continuous. But sometimes rational functions are not. We need to make sure the denominator does not equal 0. So take a look at this first one here. It says use direct substitution to evaluate if it's not possible to use direct substitution. We're going to explain why. So this is a polynomial. Direct substitution definitely works. If I plug in a -1, this gives me -3 plus 5 times a -1 minus 2 plus a -1 plus 4. Of course, -1 to the 4th is just 1, -1 squared, just 1. So this is -3 minus 5 minus 2 minus 1 plus 4. It's a -8 minus 2 minus 1 plus 4. That's -10 minus 1 plus 4. That's -11 plus 4. So the limit as x approaches -1 for this polynomial is a -7. Over here, let's take a look at this one. This is a rational function, so as long as our denominator does not equal 0, then we can just use direct substitution to evaluate. So this would be 2 times 3 cubed minus 6 all over 3 minus 9. Well, 2 times 27 is 54. 3 minus 9 is a -6. This gives us 48 over -6. So this comes out to be a -8. The limit as x approaches 3 for this function is a -8. Finally, this last one here, notice if we do put in a 1, it doesn't work right here. If we put in a 1, we get a denominator of 0. 1 minus 1 is 0. So we cannot use direct substitution. We cannot find the limit using direct substitution. But this leads me to our next thing that we're going to try. If direct substitution doesn't work, try to factor and simplify our expression first. Notice right here we can factor the top by difference of squares. This leaves us with x plus 1. Well, now we can find the limit. This is a polynomial. We can find the limit. We use direct substitution now. So first we simplify it and then use direct substitution. We put in a 1 and the limit would be 2. As x approaches 1 for this function, the limit is